Hello friends, welcome to our channel. Here we'll look at problem 778 again, swim in rising water. In this video, our method will be binary search with the help of depth first traversal. So in the previous video, we solved this problem using Dijkstra's algorithm. So here, the method is a complement of that video, especially in view of this assumption. So the value in the grid is bounded above by n squared, right? So this gives us the natural search space. Now we're not going to go over the problem statement, but we want to mention two things. First, this sentence, right? And also another one. So you can travel from one cell to the other cell if and only if the two cells have elevations less than or equal to t, right? So with that said, let's focus on the coding part. So actually we have a playlist on binary search. So binary search is very widely used, and it can address quite a large number of problems and quite a large types of problems in LeetCode. So here the binary search we are going to explain has two parts. One is define the Boolean function to produce order or produce monotonicity. The second part is fix search space and then do search space shrinkage. And in between, we are going to get the result. The intuition here for this problem is that if t is large enough, for example, t is n squared, right? Then we can always reach the bottom right corner. So then the problem is reduced to find the minimal t such that the bottom right corner is reachable from the top left. So that forms our main thought process or main observation. So now let me write the code. First, let's get the size of the grid. It's an n by n grid, right? So the directions or moves are 4. So 0, 1, 0, -1, and 1, 0, and -1, 0. This is very natural. What we want to do is we write a function, let's call it DFS. So this is a position x, y, and then given a time t. So we want to check with before less than or equal to t, can we reach to the bottom right? So this is the Boolean function. Then using this Boolean function, we are going to do binary search. First, let me write the skeleton of the code, and then we implement this DFS function. So here our search space will be this. The low will be 0. The high, so actually it's bounded above by n squared. The high you can choose much larger, but let's choose n squared here. That will be large enough. And the answer, so we are going to set it to be float infinity, right? And then what we want to do, so the search space shrinkage, while low is less than or equal to high. And then we can do middle. So the middle will be low plus high divided by 2. So this is the one way, or some people like do this, low plus high minus low divided by 2. So each time you shrink half, right? So then what you want to do is initialize a visited site. So here we can do say false times n for the dummy index in range m. So here actually you can use a set or two-dimensional array. In the previous video we used a set, so now we are using two-dimensional array. So we are going to check if grid at 0, 0 is less than or equal to this mid, and if using this term, so from the beginning, that is 0, 0, and use this term, can we get the end, right? So if this is the case, so we can first update answer to be made, then update high to be because we can reach at mid. So high will be at most mid minus 1, right? Otherwise, the low will be mid plus 1. What we want to do is to return the final answer. So this part, this is the here, the fixed search space, right? This is the search space. This while loop is search space shrinkage. So here we want to implement the Boolean function which produces orders. So here we can use DFS. In the previous video, I mentioned that I'm going to use BFS. For sure, you can use BFS to get an iterative implementation. But here in this video, we're going to use DFS rather. So we can write in terms of using recursion. So first, we want to check if x equals n minus 1 and y equals n minus 1. If this is the case, we actually already arrive at the destination, we return true. Otherwise, let's first update this is the either a set or 2D array. So let's update this xy to be true, meaning that I have visited this one, or this one is reachable. Then we are going to check the new position. So dx, dy in directions. So the new position will be x plus dx and y plus dy. Then we are going to check the neighbors. If 0 less than or equal to nx less than n and 0 less than or equal than ny less than n, this means the new position is inbound. And also we request that it's not visited yet. So we're going to say not visited. The new position, new x, new y. And also we request that this is large enough, right? So we want to create nx and ny is less than or equal to the t given in the argument. This means that we can reach that position, right? Then we can check if we can arrive at the destination from the new position. So it's nx, ny, and t and with. If this is true, so we are going to return true, right? Otherwise, finally we just return false, right? So this is the full implementation of this function. So I hope that this way of exposing you the information helps you realize the architecture or structure of the code. Before we make any further comments, let me first do a test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes the generic cases. So now let me mention this one. So here we do this, or we can do, let's see, we can do this, right? We can do mid equals this one. And then we comment out, and then we run it, submit. Yeah, so this will be the same thing. Personally, I feel that this way is more intuitive in terms of the wording, like shrinkage, right? Each time I shrink half, right? So, but that's the personal choice. But you also need to pay attention to here. We write less than or equal to. For some problems, due to the problem logic, you can write strict inequality. But for some, you need to write less than or equal. So if we run here for this problem, right? So this is not right. So you need to write less or equal. So this is the first two comments. So the next comment is that we have a playlist in our channel on binary search. So that there we use binary search to solve different leetcode problem in different use cases. So I guess if you can walk through or study that playlist, it will help you understand better this problem and in general the strategy of using binary search to solve general problem. Lastly, if you found this video and the channel useful, please thumbs up or share with your friend. Thank you for watching.